Can you see these folds in this rock? This is amazing. Right, let's talk about these folds. Welcome back to Rock of the Week, and this week we're going to talk about marble. But know your kind of marble that you're used to. A kind of marble that actually is marble in geology, because people think that marble is like the marble worktop and that, but it's no. This here are interbedded layers of marble, which is metamorphosed limestone, originally deposited in a marine environment as a limestone made up of primarily calcite, calcium carbonate. And it's interbedded with semi-pelites and pelites, which were original mudstones. Probably a little bit calcareous, right? Calcareous mudstones and limestones, marine environments, transgression of sea levels, deposited back during the period of time there was no life at all, right? So this and these rocks here are around 600 to 700 million years old, right? They're part of the orogeny group of the Dalradian supergroup, right? And we can see so much has happened to them. We have our original beds here. We've got our original beds of all of these sedimentary layers, but why are they all squiggly? Why do they not look right? Well, this is the next thing that I'm going to talk about. The reason why they're all squiggly is because they've been pushed and squeezed and folded during what's known as the Caledonian orogeny. There's actually a really good example of a lovely fold over here that I hope you guys can see. Like, look at this. It's like folded in on itself. Now, the cool thing is about when you come here, geologists can look at the rocks and they can tell you a story about what's going on, right? They can tell you by looking at the different structures within the rock what's happened to that rock, okay? By looking at these structures, structural geologists can then put a picture together. Now, the thing is about these rocks, they were originally sedimentary. They've been metamorphosed over and over again during the Caledonian orogeny, where you had the closure of this Iapetus ocean, okay? Now, as you had this closure and one plate subducted underneath the other one, that closure caused like a continent to smash into our continent. We were part of a continent known as Laurentia. We were attached to Canada and North America and Greenland and that, right? And as this other continent, microcontinent known as Avalonia, which is where England was, right, smashed into Laurentia, it caused this massive mountain building event, right? And orogeny, that's like what orogeny means, it's Caledonian orogeny. So as the two continents collided with each other, it caused metamorphism to happen. You actually had first to impact the Dalradian supergroup, there was an island arc that smashed into Laurentia first, which deformed most of these rocks in this area, right? Now, they've been deformed a few times, up to 4 times. We can see 4 different deformation events. We can see 4 lineations, like what in most cases, I mean, I'm blind as fuck, so I can't see it, but a structural geologist would be able to see it, right? And we can see all of these other like features within the rock that tell you about the deformation. Here is a good example of F1 folds that have been refolded, and then like F3 folds as well. So you've got so much going on here, it's absolutely mental. Like, you've got folds within folds. And they were all originally sedimentary rocks that have been folded during that Caledonian orogeny. It's proper madness to see these things in rocks. Rocks tell you a story, and I'm going to tell you that story. Come along on a tour with me. Learn more about the geology of Scotland. It's proper mad stuff. Why is it so close to me?
Imagine you're deep down in the high-grade realms of the Metamorphic highlands, where the Earth's crust is under such heat and pressure that part of the rock actually begins to melt. That gives you Migmatite. The name itself even means mixed rocks. And it's when the rock is heated that much that parts of it actually melt.
Oh, these are beautiful. These are stunning. Wow. The thing is about geology is you can't just look at the rocks above because they're no fresh. You need to look at these ones right next to the beach. It shows you the true colour. They've been polished. They look amazing because of the waves. See the true colours of these bands here? Then the folds, look at that fold there, right? It goes like that and then that. It's proper madness. Oh my god, look at this. Look at these folds. They're everywhere. Oh, these ones have veins in them. Wow. So you want to learn more about the geology of Scotland? Learn about how these folds formed. Learn about the age of the rocks in Scotland. Well, you now can. You can come along on a geological tour with me and learn about these rocks. Look at them. They're absolutely stunning. Scotland is known as the birthplace of geology because of these rocks, because of James Hutton. There's all this different stuff. It's proper madness. And now you can learn about it with me, Scottish geologist. Thank you for appreciating me and following me on this journey.